Hey, hello, this is David the Hilster, and I am streaming live here on Friday night, and it says that it's popping up all around, and I'm welcome everybody. I know it takes a few minutes for everybody to get here, but I've got a new stinger video out that I just made for my channel. I'm going to do a little upgrade here, you know, the same old spiel in front of all my videos where I say, hey, do you want to be science woke, etc., etc., tens of thousands of, you know, the whole spiel. But tonight I'm going to show you my new stinger that I just got done. It's pretty cool. It's going to be the head and the front end of all my videos coming up. And today we're going to talk about some really interesting stuff, and that has to do is what do you do when you are confronted by a mainstreamer who is out there to convert you or to let you know about how you are wrong. What do you deal with them? Especially because they come a lot of times today, instead of yelling, well, you get the dumb ones, of course. You get the ones that are just saying, hey, you idiot, just call you names. But there are other ones that come in with this attitude of, hey, all I need, just give me some of your time. Do you want to debate me? I'll be able to talk with you, and I'll bring you around. That's basically what they're saying. But we're going to talk about that today. I'm going to take some of my own comments and have those, take a look at those. So I'm going to be waiting here for people to be joining in. Sorry I didn't make it last week. I was out of town, but tonight I am here. So let's see how we're doing. And there we are. I see we are live. So I hope everybody's doing well tonight. And we are continuing to work on our Science Woke website. I'm getting people to add to that website. I just had Ray Gallucci. Ray Gallucci is a really great scientist in our group who does a lot of great analysis. He always says, well, I don't have my own theories, so I just do lots of analysis. And one of the articles I just put up there that he had contributed to, which is one of the articles he he put in our proceedings this year, 2018 proceedings, and he presented at the University of Connecticut, was one on the density of galaxies, and that is the galaxy density, if you look at it, doesn't support the idea that all these galaxies exploded out of the Big Bang. In fact, it shows pretty much more of a steady state or just sort of randomness, not what you're supposed to see if you see a Big Bang. So we're working on it, folks. It's just a lot of stuff. I wish I had, you know, Sugar Daddy to come along and say, hey, here's some money and help me out with it. But I do have, welcome you guys. Thanks for coming in and joining in. It's good to see you guys. And I will be answering questions. So if you do have questions, let me know. But I am here making some comments. Hello, everyone. People starting to join. And like I said, I've got something new to show you. I'll probably show you a couple times tonight, and you're going to go, oh boy, getting tired of that. In fact, you're going to get tired of it because it's going to be a stinger. What's a stinger? Well, a stinger in video terms is what you put out in front of like a YouTube channel where you put some little logo thing and some animation to say, I'm here at Dissident Science. So I have it. And I see people are popping in and out already. But anyways, I will be talking again about how do we deal with comments from people who are mainstream. Of course, you're going to find that in your regular life, because if someone asks you about something in science and you really start telling them the truth about it, in fact, you will get a lot of questions about this. So you guys ready to take a look at, hey, Lisa. Launching with Lisa Dissident today. Hello, you're late. Well, everybody's late tonight. But I'm glad you joined because I have my new little video I'm going to show you here. You guys ready to see that? I've got 5 people here right now. 5 very important people. I will show it a couple times throughout the night. So, without further ado, my new stinger, which is the video you tag on front of your videos before you start. So here goes. I hope you enjoy. Turn the volume down because it's pretty exciting. Here we go. Very short, though. Hey, was that pretty cool? What'd you think? Or did you see it? I can see the delay. I'm watching myself on my phone. I'm watching it over here to make sure I've got it all. You got to monitor it. But I see, yes, in fact, it comes all the way through. So I hope you heard it. Did you guys hear the audio on that? I hope you did, because it does have audio in that. And I did test it and record it, and it did come through. I'm hoping it did. So if you could indicate in your comments if that was with some comments, that would be super. I can play it again a little bit. I like it, and you can play it again a little bit. All right, cool. My daughter approved it, so she also approved my latest face on my. I make these little graphics, and some people don't like them. The graphics that I put on, they're called thumbnails. And normally what happens in thumbnails, people just let thumbnails be thumbnails. And one of the things you learn after, I'm coming up to 2 years in May, is that you want to do everything you can to attract attention so that people see it. And so I make thumbnails that, are marketing wise. And my daughter did like it. See if I can grab that thumbnail here. Oh, let's see how I can do that here. Get that here. If I can get that up. Oh, I know what I can do. Probably I can put that on the screen, or I can put that. But I do make these thumbnails with a graphics program that I have, and of course I'm talking about things where I have to go find them. Let's see here, YouTube. I won't show it to you there. But again, if you do have your own YouTube channel, you may want to think about it. It is something that really does bring attention to it. And so let me go to my channel here, and I will show it to you as soon as I get there. But I didn't used to do that. I have a lot of videos in the beginning. I have over 220 videos now, and they certainly don't have all of those. Oh, there we go. So I don't know if I can show that bigger. There we go. So I'll show you guys. Let me move this over. The browser. There it is. And there you can see right there, the one right next to where I'm going. So basically I just take myself a picture, I put it into my graphics program, try to think about the, some title that's going to look interesting to somebody. And that way you attract attention to your channel. So some people ask me, why do you do that, Dave? It's so... but it's been working. Not the only thing, but there's lots of things you have to do to make yourself well known. And that's what one of the things I do. And I have been getting a lot of new subscribers. And if you're a new subscriber, I really do thank you for coming by and subscribing. I had one day, I had 16 new subscribers in a day. I think things are starting to move forward. I'm going to have an interview with Pyro. Hey, Pyro, you around? Pyro, I think tomorrow I'm going to have an interview. I don't know if it's going to be live, but I will check my emails and find out. Oh yeah, loud and clear. Okay, someone said they saw my stinger. Yeah, that's what I need. You're sitting at work, supposed to be working, or like me, I'm a computer programmer, and oftentimes we're compiling, and there's not a whole lot we can do because our computers are wrapped up. So we'll go and watch something, and then it turns out that we'll put something on the air that goes, makes a really loud noise. So, but it's pretty cool. I'm trying to up it every, keep things updating as much as I can. I can actually do that stinger with the OBS. OBS is this program you can get for free. Everybody pretty much uses it, and it's a broadcasting live system. That's why you can see me switching all the slides there and all that. What am I doing? A tutorial on how to do YouTube's today. But I do have some news for those people who are subscribe to my channel and who follow me a little bit more closely. My my dad and I are changing the book again, our book. It doesn't really change too much in the sense, well, we decided we are going to write a physics book. And the physics book isn't a physics book that's going to teach all of physics. It's really interesting because my dad, every time we get together and we talk, I said, you know, we need to write this book as if we're just teaching our particle model as if it were true. Now, for those of you who don't know me, my father and I are the biggest skeptics of our own model. We sort of stumbled upon it by things that I had gathered over the years, and something my father had come up with a solution to the wave particle duality. And we've been writing this book over and over and over and over and over again. Yeah, right here. Well, look at this. I mean, we've got even different covers for it. I mean, it's just like, oh, here's a cover. And then I have a cover. And we got another cover. It's if you go to cover.universehack.com, you get the other. You get the what? Universe cover. Huh. Having trouble finding the site. What? Universe hack. Come on. Do I get the wrong? Don't even know my site anymore because we have been off the book. So no, not off the book, but talking about and working out. My father's working actually on some really great stuff for. Oh, come on. Where is it? My father's been working on his channel, but he's also working on the. Gosh darn it! He's been working on. Electronics. We are going to, in our book, explain electronic components according to our model. And the way I would explain our model to people, and that's not what my main topic for tonight, but for those, the way I would explain it, it gives you physicality. So the physics book is going to be a physics book that's going to tell you all about the physicality of everything. No one ever tells you what physicality is. No one ever tells you what light is. Really, it's a photon. It's a wave. They don't have ether, so they don't have it going through anything. Even if it was, they don't tell you what a magnetic field is for real. What it is. It's just mathematics to them. They can calculate things, they can make rules for it, you take tests on it, you spit it back. But the thing about the model my father and I are working on, it's like, don't you want to know what it's made out of? What is all this stuff? When you do the double slit experiment where you put light in and you have these double slits and there's this interference pattern. How's that work? And why do, if I put a detector there to try to detect which slit something's going through, it changes, it looks like it changes from a particle to a wave. It's crazy. Isn't there a physical explanation then? If you have that, can you explain that? A physical explanation for electricity, the way resistors work, the way batteries work, the way circuits work. I'll give you an example. I'm giving you an example of something very interesting about our model. If you look, my father is an electrical engineer for over 40 years. He is in the tops in his field in the sense of he was always in research. He was always a designer. He was in telecommunications. When people had circuits that didn't work, they gave it to him. He would go into his office and find problems that no one could find. So he was an extremely good engineer and extremely good electrical engineer. And I was thinking to him, I said, you know, we got to apply our particle model, which started in 2015. Nah, man, that's a lot. We're going to come up to 4 years. 16, 17, 18, 19. 4 years we've had this. And I said, you should apply this to electronic circuits and components and see what happens. Believe it or not, for those people who are not electrical engineers, and you have a circuit, let's say you have a battery hooked to a switch, hooked to a light bulb, and then from the light bulb back to the battery, the other side of the battery. That's a simple circuit. You turn on the switch, the battery completes the circuit, and voila, you get light from the light bulb, energy, electricity coming from the battery. Well, it turns out that the way physics describes electricity is they explain current. I'm sorry, current. Okay, the current is going around a circuit. Okay, I think everybody pretty much who knows a little bit about science gets that. You don't have to be, you know, super science nerd to know that. You know what they say current is? Current are the holes. Listen to what I'm going to say because it's so stupid. This is what they say. I'm not saying this because people don't. This is what, if you ask a physicist to explain current to you, this is what they're going to say. It is the movement of holes, not things, the opposite things. You know, here's a hole. Okay, there should be an electron in here. Here we go. There's an electron in here. Okay, current is the electron goes this way, which is the opposite of current, and then the hole moves that way. So it moves into another one here. Okay, I'm sorry. Here we go. Moves this way. And so then I move this over here. So it's moved over here. And of course there was a hole here. This is the current. Now this one's going to move again. And there's the hole there. So the hole moves in the opposite direction of the current. That's what they call current. That's the physicality of what they call current. Now, if this is the case, don't you think we need to have somebody at least come up with a model that tells us exactly what that is? Well, Glenn Borkert, who has an ether model, said, well, there are waves in ether that's contained in a wire. So that, you know, it'd be like you have air everywhere, but I have a tube. So if I blow, you know, if you have a tube and I make a sound, that sound stays within the tube and goes out. He says that's the same thing that's happening with ether. In our particle model, it's different. They're just particles. So we have particles going through a circuit. That's it. But anyways, that's something. So our book is now going to be a textbook, and it's going to teach people what things are that we don't have explanations for. Oh, this is what gravity is. Oh, this is what light is. And it's not going to be anything that needs anything but an explanation. And we'll draw pictures. There's no equations needed for you to understand that. There's no equations needed for you to understand how the circuits work in reality. You know, I've talked about this before, but all of these things are going to be in the book as a textbook. So someone can pick this up, use it, and teach somebody, oh, this is the physicality of the universe according to the particle model. Are we right? Are we going to win a Nobel Prize like everybody says they are? Everybody with a model says we're going to, if this is right, we're going to win a Nobel Prize. I don't want to win a Nobel Prize. I'm not going to win a Nobel Prize. I'll probably be dead and gone before, even if this model was right, we'll be gone. And besides, the Nobel Prize is given to a bunch of nonsense. So we need to come up with a better prize. Here you go. This is what? A battery. So this battery contains energy, which is a concept. So what is this? It's got electrons inside, and it's you know, positive and negative. If you put compasses around a battery, and we have a picture of this in our book, it acts just like a magnet. So this has a magnetic field. And this means, as I hold this, not all of the energy is inside. Now, you're thinking, Dave, that's crazy. Well, let me tell you something about how this is crazy or not. What am I doing? I'm just talking about the particle model tonight. I'm just going to go on with it. Okay, here you go. Apple Watch. There's the back of the Apple Watch. What happens? Well, this isn't the right one. But let's pretend this is the Apple Watch charger. Okay, it's a round thing. I don't have it with me. I can go grab it, but I don't need to. Okay, so it's a round thing. You put it on here, and it sticks. So this has a magnet in it, and it sticks. There is no direct contact with the magnet. The magnet, there is no line. Whereas when you have one of these and you have a phone, you have a direct wire. A direct wire going to it. So what do you have with a direct wire? You have the electricity flowing up there, or the holes flowing backwards, current, which are holes. I won't even say it. That's why it's just so ridiculous. So the electricity, what's called electricity, is flowing through this wire. When I do it with the Apple Watch and I put it on top, or the new Apple phones, or the Android phones for people who don't like Apple, you put them on top, and I think it's inductive or something like that. It's charging. It's like wireless. In fact, you can charge it by not even putting it exactly on top. It doesn't necessarily have to touch, because it's really not. The battery's inside and it is separated. What's going on? Well, the problem is we don't have a physical explanation for that. But if you have a model, like the particle model, we absolutely do. And because magnetic fields are real things, are real stuff. Where's my, oh, there it is. That a battery, according to our particle model, must be something real. And in fact, it's got flowing particles, G1 particles, which in our model, the particle, all these particles go at the speed of light. Gravity goes at the speed of light. If you don't believe me, look at the Wang eclipse. Even look it up, the speed of gravity. Mainstream science says it's c. During total eclipses, the Wang eclipse shows that gravity and light arrive at the same time. Speed of c. Gravity, light, electricity. Guess what? Why aren't they all the same particle? That would make sense. So that's what this is. So magnetic fields are the same thing as electricity, are the same thing as gravity, same thing as light. It's just in a different form. Just what happens to be electrical in the universe are lots of particles flowing together. That's what makes things electric. Gravity, on the other hand, is just random particles that create a field and all that stuff. But going back to the book, the reason we're going to write this finally, we're going to write it. You're going to pick up the book, and it's going to learn. You're going to be able to teach a class in it, and it's going to say, "Hey, you can describe the universe with this model," and you are now going to be able to say to someone what it really is, why atoms stick together. Why do they stick together in different ways? All of that stuff. Without any equations, without being any super person, you just have to know a couple rules, and the entire universe is constructed from that. So that's what we're going to do. And it's not going to have, our physics book is not going to have in it teaching of all physics. The idea, it's a supplemental physics book to tell you the physicality of everything else you never get in physics. So I think it's pretty darn cool. I'm the first to tell you, and my dad is, that we're doing this because we think this is the best way to teach it, or to understand it. We're not here to tell you that this is the way it really works, but I will say the model works pretty darn well. And even if it's all wrong, it's certainly a first step, in our opinion, to give the world physicality where we don't have any. So those people who are on my channel and who are subscribers, I thought that would be an interesting story. Before we get to our topic tonight, which is how do you deal with questions in the comments? Boy, I had a whole set of comments on a video where the guy is coming in to save me. I will save you. I will save you from yourself. The reason you don't understand space-time and general relativity is because You don't understand it. All we have to do is explain it to you. There's a really good video that I have about these two, I think it's in Denmark, these two physicists who were disputing the gravity wave findings, saying that they were noise. And what did the people who found the gravity waves, and then some of them win Nobel Prizes, do? They spent the next 2 years debating it, or maybe going through and finding out, you're right. It was noise that we saw. This is wrong. Here's my Nobel Prize back. Can you imagine that? There's just no way. I just think it won't happen. I don't care if they won it for invisible frogs. They will not give it back. Oh, here's your money back. Here's my reputation back. You can have that all. I was wrong. Let's go forward and see what's really going on. Well, in that, if you go to that video, go to gravity waves dispute or something, dissident science, gravity wave, go to that one and you will find there what do these people who want to teach you. Basically, the theme's real simple. The reason you don't understand it is because you don't understand it yet. You're either too stupid or no one's explained it to you well enough. And that's what they did. So they spent 2 years going to this place in, I don't know, Denmark or somewhere. Don't quote me on all these places, but two physicists. And they were saying, we spent 2 years trying to, what? Put a funnel in their mouth and shove down what we're saying. And what they only do is repeat what they're saying. So anyways, let me, before I go on and talk about this, let's make sure I have anybody here that's looking forward to that pyro info. Yeah, that's going to be good too. Dave, that sounds great. I'm going to have to go to bed now. Okay, that's really cool. Yep, right-hand rule. Yeah, the right-hand rule actually is really interesting in the particle model. Go to Particle Guru right-hand rule. My dad will explain it to you using our particle model. A real physical explanation why that exists? Oh my goodness. Are nuclear forces the same particles as light, electromagnetism, and gravity in the market? No! Great question. Atom lore. Here's what happens. Very interesting in our particle model. Not because we decided this. This is what came out of it by just our logic of putting together what we think is the right components and how the universe works. So let's say these are two magnets. The question is it the same particle that is, the nuclear forces are the same particle as light? The answer is no. So let's say these are two magnets, and I'm going to do it this way. This is a magnet up here, and this is a magnet down here. If I let go of this one, this big one down here, and I'm close enough, this will come up here, hold on to this, and not fall down. Okay, that's what it's going to do. It's not going to fall down. I'll just be like this. And that means this magnetic force is way more powerful than gravitational force. Now, gravitational force in our model is caused by gravitons, which are the same as light, gravity, and magnetism. The flux, the flowing particles for magnetism are all the same particle. So the thing that makes this fall, which I can demonstrate, that's caused by what we call the G1 particle, or the particle at our level that does most of the work in the universe. Well, because we don't believe in magic, we have to, then we subscribe to infinity. What does that mean? Well, we say that no matter what particle you have, there's always particles below that. And there's no particle, you know, a sun is a particle, a galaxy is a particle. Because if you look at it from afar, it's just like a dot, it looks like a particle. So what we call a particle is mass. Doesn't matter. Mass that's, you know, together, and then there's less mass in between it. So you have these particles. And what happens is when this force, which is much greater, you're thinking, well, why is that? Well, it turns out that let's get the battery back. For here, this battery, we have G1 particles in all directions. You see the light that you're seeing here are organized. That is, they're just waves of particles. Just think of it as digital information. We send digital information across um, fiber optics. It's the same thing. We send pulses of stuff. That's the same. That's all light is. It's pulses of particles. It's not one particle. You can't get away from one particle. It's impossible. You can say there are particles that make it up, but there is no such thing as a photon. So anyways, going back to that, what you have is you have all of these G1 particles, which is electricity, light, gravity, whatever. It's all going around in circles. It's all captured in here, and it's moving all together and flowing. This one's not so easy. Magnets are a lot easier. Magnets have direction. These guys are a lot more complicated. Won't get into that right now, because it's not just won't get into it. Anyways, all we can say is that this has a lot of stuff flowing around it. Now, if this is a magnet, okay, this also has stuff flowing around it, but this is much more organized. It's flowing, 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 flowing. How does this particle go around and come around again? Why would a particle, well, do we have any analogy? Yeah, here's the Earth, here's the moon, and it goes like this. What's causing that? Well, if you put a field all around it, all these particles, imagine ping pong balls flying in all directions, and they're just flying in all directions. They're hitting these. If this is all by itself, it's pretty much going to stay in itself. It's going to be hit by impulses all the time, but it'll be sitting there. If I put this in here, what happens is the ping pong balls going in these two directions, it's called the shadowing effect, cause right here in the middle less pressure. So it wants to come together. Now, of course, if I'm moving, then that's what happens. So curves, particles that are curving, can't do that just because we say they do it and write equations for it. There's got to be a physical reason. The physical reason is this. It's real easy. This is the Earth. This is the moon. What keeps this orbiting are G1 particles. Gravity, gravitons. That's what keeps this going. All right? Okay, let's go down a level in the universe. Let's go down a level in the universe. What is that? Well, let's go down. What happens? This is the nucleus of an atom. This is an electron, or G1 particle in our case. So this is a nucleon, meaning in the nucleus, because even today, particle physicists, oh my gosh, don't say it, but it looks like there may not be neutrons after all. We call things that are neutrons. Be careful. I'm not saying that because I just make it up and believe it. We've got people who follow particle physics today, and that's becoming more and more accepted. You have protons. But anyways, that's why we don't care, because we don't have charge in our model. So this is a nucleon. It's a particle that's the big particle, the heavy particle of a nucleus. This is the nucleus. This is an electron, or this is a G1 particle. So if you go up a level, and this is the Earth, and this is the moon, G1 particles are the little particles around there that makes this. Well, guess what? We're gonna go down. Now, this is a nucleon. This is a G1 particle or electron. It goes around. Why? Because there's another level of gravity. When you go down further, we call it in infinity the G2 particle. So the G2 particle, which travels way faster than the speed of light, makes the, let's call this a magnet, makes the G1 particles do this. Because there is a G2 field of particles. Fields are just particles going in all directions. It's just random particles going. I have a field of gas around me. So the answer to the question, what is the nuclear force? What keeps nucleons together? Let's call this a nucleon. This is a nucleus of one atom, a nucleus of another atom. It's not G1s, because G1s go around these guys. What keeps the G1 going around this, and what keeps, therefore, nucleuses together, is the G2. It's one level down. This is the nucleus, this is a G, and this is a G1 particle. Other way, this is the Earth, this is the moon. It's kept together by G1 particles. This is the nucleus, this is the electron. It's kept together by one down below. So if you could shrink yourself down, you'd be traveling through atoms that'll look like, suns. and the electrons are like planets going around them, and it's kept together by G2. It's all Newtonian. There's nothing there. There's no charge. There's no positive and negative. There's no proton. There's no electron that's a negative and a positron. No. And so what the reason this comes together as this force, it's because it's actually the G2 forces that are involved. Because when you have G1s and G1s, the things that move G1s are G2. So the reason you have such a strong nuclear force, and the reason you have magnetics bringing things together that just make gravity look like it doesn't even exist, because that's the G2 gravity a level down. Thus ends my lecture. If it's all right, could be all wrong. I hope that answers that question. All right. So you doubt the wave-particle duality? Yeah, there's no such thing as the wave-particle duality. The reason the wave-particle duality exists because the model sucks. You know, that's what it is. It's a wave. It's a particle. It's a wave. And the way I look at it is logically, just logically. I don't care about the wave-particle duality. I don't care about that. Just logically. Just think of it this way. One particle can't be a wave. That's why my father came up with the model he did. One particle cannot be a wave. Sorry. So the idea that there exists a photon is absurd. Because waves and light, which is a wave, because it's got frequency, we can measure all these things. It's a plurality of particles. Gravity is one particle hitting a nucleon. Light is information. The reason we see all this stuff and our eyes see all this stuff, and I can tell what's behind me, which is a big mess. They tell you in YouTube videos, you know, to make sure you don't have a big cluttered mess behind you. I figured it's a texture. But the big mess, how we can see that, is because information has to come in waves. When I try to find what's underneath the ground, do I send one particle down there to find out? No. I send a wave. I send a shock wave. And that wave goes down and the wave comes up. And the wave, which is a bunch of, not one time, but it's hit it, that goes down and comes up. The reason I know something is blue is because information is being sent from that object. In our model, we can tell you how that works. I remember in December of 2016, God rest my mom's soul, we were literally on Christmas Day eating at Cape Canaveral. We had never been there. My father and I, my wife, who's Brazilian, was in Brazil with my daughter. So I decided to go with my parents to Cape Canaveral, never been there. And I finally, with our model, hack the universe of how and why we see color. And that's a whole different thing. What am I doing talking about the particle model all the time? Okay. So the reason is you have information. So again, the idea of wave-particle duality is because we had the photon, which Albert Einstein says, here's an object, you got to hit it, the photon has to hit it in so much stuff and it dislodges an electron. It's just a way you can have a plurality of particles. So if I shoot 3 particles out and I need 40 particles to dislodge it, then we call that a photon. So, so photons don't exist. It's a bad concept. I mean, I'm going to have a talk just about that. I haven't done that. The idea is understood is that both of our analogies of waves and particles can't fully, but to help understand what we are seeing. Yeah, it's just it's a symptom. The wave particle duality is a symptom of our bad models. That's what all it is. And I will go to sciencewoke.org, and hey, for those who haven't seen it, while I type this, here comes my stinger. If you haven't seen it, I know Lisa saw it, but some of you who have been around since the beginning, you're going to see this again. I'm so sorry, but it's worth taking a look at. It's going to be my new beginning of every video. Here we go. They got a website that renders these stuff. You put in the stuff and you could and then you pay money. But I got that in high def, so it's good. It's all mine. It's really cool. Now I'm going to show you the answer to the question of wave-particle duality. I will show you that. It's with one of my memes. Well, one of the memes I have. There we go. There it is. There I am with the same glasses, almost the same hair. Maybe getting a little older since then. And even a black shirt. This is from our Science Woke shirt. Yeah, I won't even talk about it. I'm sorry. You guys want to shoot me in the head. Where's my book? Where's the Science Woke? Well, here it is. And the universe isn't complicated and paradoxical. Our theories are. And this must change. So there you go. David Hilster, one of my sayings. I always come up with sayings. You know, I have one. I came up when I was 8 years old. I said, no one knows until the wind blows. I was in a kite flying contest, and I thought that was cute to come up with at 8 years old. But anyway, because I'm just telling you, I like doing sayings and ideas and things like that. But I have it. If you have, oh, you can't go to that yet. It's going to be there. You can go to CMPS memes. So, alrighty. Thanks for sharing your ideas, though. Provide for sure. Isn't there an issue with stability of the solar system model of an atom? There is, because they don't have a idea of how this all this stuff works together. The only reason there's problems with the atomic model is because they're using their equations. I do have a degree in math, a bachelor's of science in mathematics, advanced calculus to be exact. And the problem is they get into their systems, they get into their mathematics, they get into the way they came into the problem. They then put up some type of straw man, so this can't be, so we have to come up with something different. The whole thing is that they did not have infinity. They did not have the idea that that you could construct or try to construct the whole world from a Newtonian world. And so, yeah, I'm sure if we were to look at it, what we would say, this is my guess, this is a good question though, very good question, is that my guess is that we would probably use our own model, explain to the person who's the explanation of how an atom how it doesn't work, and explain to them how it in fact can work, and how that the reason that they say it can't work is because they have a model that's paradoxical, or it's got something in it which they assume that is incorrect, or they assume something that they don't really know how it works, they just say it's that way. That's normally what we find. I'll give you a good example. Well, Dave, what are you talking about? The electron, how could the electron be not just one particle and a lot more particles? Meaning what we think is that a hydrogen atom doesn't have just one electron. It has actually more than one particle going around it. In fact, we think that because if you look at the periodic table, it doesn't have integers for the electrons. It's got 1 point this and 2 point that. How could that be? Well, because their system isn't correct. But anyways, appreciate people staying around. Photon came from an idea of a photon, which is a pseudoparticle. Yeah, it could be. Feynman said that light is a corpuscle. I think if Feynman were alive, he'd be intrigued with my father's idea of what light is. For those who want a good analogy of light, gravity is your shower turned on with normal. Random drops coming at you in one direction, more in one direction than another, but let's just say representing the force of gravity. Light is when you turn it on to shower massage. Say that fast. So basically what all light is the same thing. It's just coming into you in waves. and that's all it is. So when you turn on, and you don't need a whole lot of them to get that information. So it's not like, oh, well, then how could you have gravity and you have light going through it? Well, there's mostly space happening there. And even if you look at it just information, because we're obviously getting information in my eyes. I can look anywhere and see like my father's face from any angle. So information is coming to my eyeballs, and that information is transmitted somehow. And one of the things is how could you have all these particles transmitting, and won't they all interfere and bash into each other? No, because if light is super fast, and we calculated that actually from a star that's billions of light years away, that you need only particles of that light, not photons, but G1 particles coming to you in groups 5,000 kilometers apart. So you have 5,000 kilometers apart between particles for me to see that light, because when I speed it all up, I'm seeing a star without it ever blinking or giving me a funny picture of it. So yeah, corpuscle, nope. He was not into this whole wave-particle duality stuff. He was a strong proponent of the particle concept. Yeah, I think if he would have understood what my father found, someone said, somebody like in our group had also mentioned this, but I don't think they took it very far. Could be that other people have sort of stumbled upon it but sort of threw it aside, is this idea that light are waves of particles, not waves in particles. Then I think he would have been very interested in that. Derek was also into particles. Yes, nice graphics on the intro clip. Yay, cool, thank you very much. Lambda, your G levels push the real mystery down to the next level. Give Lambda a cigar. Absolutely, of course. I am a proponent of infinity. I like that concept because the idea that you have a magical particle at the very bottom that organizes itself, I believe that, yeah, you go infinitely down, that protons are made of, or nucleons are made of particles. There's probably a whole nother set of particles with a whole nother periodic table. Jeff Yee and his model, which is more of an ether model, he has a periodic table for the subatomic parts, just like people have there's periodic tables for the atoms. So yep, it goes down and it goes down, and that comes to Borchert's 10 assumptions. Scientific assumptions. You have to read that. Scientific Worldview, get the book. Scientific Worldview, or the Infinite Universe Theory. Oh, I do have a page. I've probably shown you, but some of you who are not here every week, which I of course know that, and I'm going to get to my, very shortly I am going to get to our topic tonight, but let me do this one other thing, which was, I was talking about, I just lost it. The wave. Oh, somebody can remind me. I just lost my train of thought. That's why I'm sort of a creative person where our heads go in a lot of directions and we finally find something. But I was talking about something. So if you do type it down here, I know there's a delay. So anyways, I'm sure I can keep talking and talking and talking on those. But if someone can remind me of what I was sort of talking about before then. Alrighty. If not, that's okay. I'm going to go to the next thing. Oh, I remember! DissidentScience.com. I actually have a website. Let's take a look at it. Here we go. There I am. Oh, and there's that picture my daughter thought was sort of funny. On here I have something very nice, and that is if you come over here, I'm going to move my windows around. Come to the menu, because this has been squashed. This is what you would see on your tablet. I made it squashed so we can see it on my screen. You can go to recommendations. So those of you who don't know this, go to my site, recommendations, click on recommendations. I have books to read, the Higgs Fake, Dinosaurs and the Expanding Earth. Infinite theory, infinite universe theory videos. You got to see Yonel Danu's underwater experiments. That's why we say that magnetic fields are flowing particles. The absolutely fantastic videos and graphics of The Expanding Earth by Neil Adams, which has probably more views than any other dissident science work. If you want to see real geological explanation of the expanding Earth, you can see that in this series of lectures with James Maxlow. Here's Infinity and its assumptions. Glenn Borchard on natural philosophy, one of the great scientists. He's of our time in here in the infinite universe theory. There's also another book I should really put in here, which is the Scientific Worldview. You should take a look at that one. Movies you should see. The Miracle Year, if you want to see that, haven't seen it, you are a subscriber of mine. If you're here especially, I can easily give you a free rental of that to watch online. The reason I do that is the couple $100 that comes in every year, which is much, pays for it to be there and for people to be able to see it. So, and there's also the Cosmology Quest, which is a person I know, Randall Myers, who made this in 20 years ago. It is not the most exciting thing to watch, but it certainly brings down the Big Bang, and that's all online, so you can see it. It's in actually a couple places, but for those of you, I thought I would show you that. So if you haven't gone to my site, I am doing that now and trying to, in fact, get that filled out even more, because I say I gotta have a place for recommendations of what I would say to read, those kinds of things. I'm not done. I just put those up there in the copious amount of time that I don't have. So now let's go to the comments. What do you do when people come by and they are making comments from a mainstream point of view? We're going to take a look at one of these. This is the evidence against the Big Bang, which is actually from Glenn Borchard's what am I doing? Where's the oh, here we go. Okay. So yeah, it's got already 300 and some views. That's quite a lot. Hey, 37 ups and 1 down. I know who the down is. He's a downer guy. And I'm glad he does it, because oftentimes he'll do videos on me, and maybe he's watched this. And I don't watch anymore what he says, because it's sort of the same things. But I know you got to have that one down, you know. Then it's more not controversial. Okay, so if I go down here, I'm going to get to a person called Frosted1030. I don't think he's here tonight. If he is, then fine and dandy. Hello. I'm not here to make fun of the person in any way. There are 10 replies, and you're going to see some of the responses I've had for him. So he says, are you a straw manning inflation, or do you just not understand the concept? What straw manning means is I'm putting it up to knock it down, or is it, he's saying, am I just putting it up to knock it down, or do you really understand the concept? Of course I understand the concept of inflation. This whole thing about the Big Bang has gone through a myriad of, I don't even know how to say it, not even adjustments, but hacks. That's what I would put, hacks, bad hacks. Because when one thing would be, the illogic part of it would really rear its head, something else would come up. So you have redshift. Well, maybe redshift can be explained by something else. Well, no, the Big Bang, there's inflation. And it's accelerating. And how they calculate it is the problem. So the answer to whether or not there's inflation or not, they keep, every time we bring something down in the explanation for cosmological inflation, meaning things are expanding, and inflation, it's really weird, because the idea is that space and time itself is expanding, that it wasn't really the universe sitting in a pea-sized universe sitting in the middle of this vast nothingness and then explodes into something, that the explosion itself is creating the universe. That is, don't ask me to explain it, because there is no explanation. There's no way to explain it. But that's what they say, this whole idea that space and time is going. So it's just, that's where it is. You can't go outside it. You're sitting in there, and there's no sense. It's illogical. It's got an immense problem. It's called the frontier problem. What's the frontier? You know, if this is the before the Big Bang and everything's in here and space and time is all here and there's nothing outside. Well, there is an outside. There isn't an outside, is what they'll say. So don't even ask. So when the guy's saying to me, straw manning inflation, I'm going to say, yes, I understand the concept very well. He would say, or you just don't understand the concept. What is he saying there? What does that phrase mean? Or you just don't understand the concept. Really? What it means is, I will teach it to you. You don't understand it. It's not that it's wrong. I mean, if this guy was a true scientist and a true critical thinker, this is what he would have said. You got to put weasel words in it, because nothing's right. No theory is right. No theory will ever be right. No theory is provable. All we can do is come up with equations and models that hopefully can predict things that we can maybe use in everyday life to make things better, so we can make things like this and make life better or worse. So you should say, well, sort of, are you putting inflation up as something that doesn't exist and knocking it down, or do you not understand the way mainstream explains it? Because I believe that mainstream is correct. That's what he should say. But he doesn't say it that way. He says it like it's an absolute truth. And that's what's wrong with mainstream physics. Big science, big physics, big cosmology, that's what's wrong with it. So I went on and see what I said. You are equating understand to unthinking regurgitation. Yes! John Bain. Good answer. Good answer from one of my subscribers, David D. Hilster. Here we go. What did I say? I'm going to read it over here because I can see it a little bit better. Frosted 1030. I understand the concept of inflation and strongly disagree with it. See, I'm arguing more like a debate. Space is infinite and does not expand. So I'm not only telling him that I understand it and that I disagree with it, because he never said that. He never said that he disagreed with what I was even saying. He just thinks there's one truth and you just don't know. 1 + 1 is 2, and there you go. Oh, unless it's binary. If it's binary, 1 + 1 is not 2. So, it's 10, isn't it? I don't know. In binary, space is infinite and does not expand. Neither does time. Time is movement. Too many absurdities is what I'm saying. Good news, the critical thinkers outside mainstream science have left it far behind, meaning the Big Bang, inflation, all that stuff. It is dead and buried. There I go. What does he say? I understand the concept of, okay, he's quoting me. I understand the concept of inflation, strongly disagree with it. Space is infinite and does not expand. Time to learn what we already know. Here we go again. Doesn't debate it. He doesn't say, oh, Dave, what are the absurd arguments so I can understand what you're saying is wrong. He's saying, oh, space isn't infinite, here's why. Here's why space can expand. Here's why. There is no explanation, in my opinion. I don't know how you can come up with it. But if he does, say something about that. He's going to have to say, well, I just believe that this is right and you're wrong. That's it. Okay, I'm done. I'm not going to convince you. But he doesn't say that. Study. See you go. Study. And when you come back indoctrinated, I understand. I understand. I can regurgitate it like John Bain said. Are you equating understand with unthinking regurgitation? Or as Alexander Unsker says, parroting? Like we have a parrot downstairs or something like close to it. And basically repeats. It doesn't understand the whistling song to that one. what's that name of that? Oh, you guys are way too young to understand that. Andy Griffith Show. Anyways, parroting. Okay, so that's what I said, and he says we study Eddington's discoveries. Yes, we have. In fact, I've been to Flagstaff, Arizona, to see where they had these discoveries and what they were looking at. At the time, study Einstein. Come back. Study Karazani. Go to autodynamics.org, because I've studied special relativity, and I've studied Karazani's argument against it, and Karazani wins. I can see the argument that mathematically you have to have more than one frame for relativity, and guess what? There is no such thing as inertial frames. So I did. And here's one of the things you can say to people. It doesn't matter what you say, because what you have to remember, one really important rule. The people around you who are listening to you. In fact, I say that here. Let's keep going here. The universe isn't here for you to get. That's your choice. That is so funny. What he's saying there is that they've discovered perfect truths, and that just doesn't exist. Let's see, John Bain. It's going to John Bain. You are equating understanding and regurgitation. Did you want to do the math yourself, or would you rather just hide it? See, what they're doing is they're saying that you can't repeat it. Well, we can repeat it. In fact, Karazani repeats special relativity so well that the idea that you can use special relativity without ether and get the Lorentz equations has a mathematical problem. Instead of 1/3, it comes out to 2/3. He's got the math. It's been checked by physicists at TRW Space Park in 1994. I've got a letter somewhere that proves that. They say that. They've checked it. They can't find a problem wrong. The problem is he doesn't want to look at that. They won't look at that. So basically they're saying, I'm a member of this society of maybe thousands, because I don't even think there's tens of thousands of people who believe all this stuff, and we are in high places, in high universities. We have big brains and you have little brains, and therefore, because of that, we've been certified and all that stuff. I can do brain surgery with this stuff and you can't, because you'll kill someone. Well, it ain't that way, because it isn't brain surgery, and you can understand the universe without killing anybody. Or you can come up with a better model without killing anybody. Like Einstein didn't do, but he thought he did, and he was a patent clerk, for goodness sakes. All right. A critical thinker. I respond to you for those real critical thinkers on my channel. That's what. Oh, here we go. And I say frosted, frosted, frosted. Now this is just silly. This is me. I always use silly because I get to the point where I can't. I know the reason it's a really great use. I use my word. It took me 10, 20 years to come up with the word silly. Why? Because you're making it. You are saying you don't believe it's true, but you're saying stupid. Stupid has a connotation that makes a person feel like you're smarter than they are. If you say silly, it means you're just doing things that just don't make sense. Doesn't mean you're not smart. So use that word, folks. So he says, now this is just silly. I always use that. My answers are not for you. You are right and I am wrong. Here's where I tell him. This is where I said, I'm not even going to argue with you. Listen to what I say to him. You are right and I am wrong. That is a fact. Okay? That I say to him. Why do I say that to him? Because I know I'm not going to change his mind. And I say, I accept that. I'm wrong. You're right. Why? Because I don't care what he thinks. Because he's not an interesting person. He's not challenging me. He doesn't challenge anything. All the people who are critical thinkers, all the people in our group know relativity better than the people who teach relativity. They know cosmology better than the people who teach cosmology. They know more about electronics, like my father, than the people who teach the physicality of what electronic circuits are. My father knows more. He's now buying a volt machine to measure to 6 and 7 digits because he thinks our model is going to tell us about resistors in parallel that's going to show a difference that no one has seen before. That's what models are supposed to do. So that's what I'm saying. Again, I'm going to say, this is just silly. That means you're just being silly. You're not stupid, you're silly. My answers are not for you. It's just true. Because why? Because you are right and I'm wrong. Do I believe that? We're all wrong. No, I believe we're all wrong. Some of us have better models, better ideas, better understandings about the universe, what we see in the universe than others. Yeah, but I'm wrong. Everything's wrong. There's nothing right. So we got to get over this right or wrong. We can just say this one's better than another one. That is a fact. So I tell him that's a fact. It is true. It's a fact in his mind that he's right and I'm wrong. So remember these things. So if you're arguing with a person, say, this is silly. I'm wrong and you're right. You win. It's a fact, right? So what's going to happen is, don't worry about me. I'm going to talk with my friends about this stuff and we'll die, doing stupid and silly things. And you'll be right and you'll go to your grave happy. And then I say at the end, I say something like, well, then again, maybe you're on the side that is refusing the changes to see the problems of today's science, and you're relegating yourself to the flat Earth society of today. But, you're free to relegate yourself to obscurity. That's fine. To be on the side of people who wouldn't let go. Then I get them like that. At least they can't get me. They can't get me with anything. Then I say, even if I regurgitate the mainstream science and their arguments for the Big Bang, you are here to save me, not to be a critical thinker. I respond to you for those real critical thinkers on my channel. And then we have other people talking. Go back and look at Edwin Hubble himself and about redshift and the Big Bang Theory. Hubble didn't discover the phenomenon. He did not claim that it was evidence for space expanding or velocity of galaxies. Also, inflation is a recent concept that comes later after they gave up on earlier falsified versions. Exactly. That's what I said. Adam, are you here? Adam! If you're still here. Boom! Boom! Adam is a true critical thinker. Waiting for the thinking part of that. So far, all we have is that you don't understand what you've been told. No, he got that one wrong. I examined what I was told, and I thought it was illogical, and I'm trying to find better answers because I think it sucks. Pretty much it. It's like saying, hey, once you go down, you've been told to go down this road to get to where you need to go. And so I walk a little bit down the road and I see there's a dead end and a cliff with about 40 cars and dead people at the bottom. So I'm saying, yeah, so far you don't understand. What have you been told? I looked at it. I don't like it. It looks really stupid and silly. I ain't going there. To put it in colloquial terms. Yeah, and so they just go on, and Adam does an absolutely great job here of talking. Inflation was developed by Alan Guth in 1979. There you go. Hey, all of you people who are on my channel right now or here live, that's the argument. I'm wrong. I have to admit I'm wrong. Because the argument is inflation was developed by Alan Guth in 79. This is exactly what mainstream media does when people who are, for instance, fighting for the people. I'm not here to say you're conservative, progressive. I'm a progressive. It doesn't matter. But when people make arguments, what they do is they bring the same arguments people in mainstream media who are going against the candidate that goes against their donors, people who pay for their channel, their $30,000 a day they get as people who are not the news. I'm going to do a video on my channel about how newscasters are the same as Neil deGrasse Tyson. They're people who spit out what they're told to spit out. It's very similar. It's very similar. And that's what these people are doing. And the truth of the matter is, Dr. Alexander Unsker says it in his book. Get the book, The Higgs Fake. You got to read it. In that book, what you see, in fact, is he talks about the people on the conversation. If you go to, better yet, if if you go to watch the conversations I had with Alexander Unsker. It was just a couple weeks ago. I interviewed him live. Well, not live. Sorry. I interviewed him via Skype and recorded it. And he mentioned something which I hope I can talk with him again, is that the people he's talked to who went into and even won Nobel Prizes, this is the conversation. I'm going to give you part of my talk already. Here it goes, since you guys are here and I do appreciate it. This is what he said. Alexander Unsker said to me, he says, I was talking to the guy who won the Nobel Prize, David somebody, Bloom, I don't know his name is, David. So anyways, I asked him, well, how'd you get into it? And I'm going to be completely sarcastic here, but this is the kind of answer, to put it in a very sarcastic and very strong way. Well, I thought about being a professional bowler, a person who paints houses, or go into particle physics. So I decided to go into particle physics. It wasn't even somebody who had this great calling to find out what the universe was. It was just somebody, I could have done this and this and this. I decided to go into this. Very much like politicians. That's why we don't have politicians with the IQ of 186. Because our system of corrupt politicians doesn't allow people who actually want to do things for people to go into it, which is changing. But that's the problem. So the people that we see and the people who are winning Nobel Prizes are not the top of their class. They're not the top people. Those people run away screaming. They go into the night screaming, get me out of here. Just like that one lady who I did the video on as well. Let me go to my homepage and I will find that. Sabine, what's her name? Sabine Hussenfelder. That's why you see a picture of me doing this. You're kidding! Times article, New York Times. Physicist leaves particle physics because she thinks it's a crock. And she's not the only one. That's the majority of physicists think that. Alrighty, let's see how many questions. Hey, Adam Lohr, there he is. What are wormholes? Well, wormholes are, if you watch my video here, let me go back. Watch this video, but I will repeat it here. Wormholes. Basically, wormholes were proposed by Einstein and another guy, which I don't remember, Holden or something with an H. And they basically said that, well, we have this problem with the singularity, and, well, you can't have it all just come to a point and then not be there. Well, if you take that singularity and sort of stretch it out like this, we won't have that problem of destination of nothing. You go in this and you come out somewhere else. Why they said that, why they came up with this, is honest to God a hack. It's a hack. It's someone thought of it. I don't know. They had a beer or they did some drugs. I don't know. That's where they came up with it. I can't think of a logical reason. And the logical reason they give, and that's what, if you look at this video right there, if you go back to this video, take a gander at it, watch it. They have wormholes in there, and there's a good explanation. There's a link to that. In fact, if I do go to that, nope, that's not the way to do it. I'll go to YouTube here. There we go. It's on mute, so that will stop. And believe I have the article here. There it is. Oh, no, that's not it. Am I telling you completely wrong stuff here? Scientific worldview article, new article on deep field analysis. Nope, sorry. I'm giving you all wrong information. I must go back to Dissident Science and try this again. It's not in the evidence of the Big Bang. It's the it's this last one I did. This very last one. What I'm talking about. I don't even know how many days ago that I'm talking about. Sorry, everyone. Erase that. Erase that one. And there I am about to say I'm going to have a new beginning, so I don't have to say that. I'm so tired of saying that stuff. either get it or you don't. Go back to my other videos. People will do that. So here we go. If you go to this article in my latest video just before this one, which was a very interesting video. If you haven't seen it, please go watch it. It's definitely worth it. You come back here to wormholes. It says that our infinitely small point within a black hole is known as a singularity, and it's a mess for physicists. In 1925, physicists Albert Einstein and Nathan Rosen, I got that one completely wrong, pointed out that it might be able to avoid the idea of singularity if you extended a black hole into a second location, creating now what we call wormhole. I mean, seriously. That's what they are saying. That's what is being said. That's what they're saying, wormholes. It's absolutely sad. It's extremely sad that's, but we talk about wormholes all the time. We have whole movies based on wormholes. Wasn't that like Contact or something like that about a wormhole? And you know, you travel through wormholes, or like tubes. I'm sorry, folks. We have to burst that bubble. So, what are black holes according to my model? Been asked that before. Don't know. We haven't hacked that part of the universe. Some of the things what we think of is it's nucleons without very close together. So you have G2 forces holding together. Here's the nucleons, and you have more than one nucleons. They're all nucleons here. They would be like probably more closer to the same size or whatever, and they don't have the space they have for G1 particles to go around them. Most likely get to the point where we do blow apart atoms all the time. Suns do that and shoot us out. It's one of the things about cosmic rays. These things about cosmic rays, what does our model tell us about? They're nucleons. Nucleons are what, 99% of the mass? If a nucleon's coming at you, if you have G1 particles, which are light or gravity, they're hitting off the nucleons. You know, they're like little guys bouncing off of the nucleons. So it doesn't, you got to get a lot of them. Yeah, if I take a laser, I can just blast through and destroy atoms for sure. Yeah, you can. You get enough G1 particles, force them, they'll hit them. But what I would say is that black holes are very dense. They're yes, there's something there. The reason you don't see light from them is obviously G1 particles, if they hit on, are either being, you know, captured, just like they say light is captured. Well, they don't know what light is, so what can you say? So most likely G1s are there. If they do go there, I think the other way is that they're not captured, G1 particles, that you have nucleons being held together at the G2 force, the gravity force. So it'd be like what a black hole would be is a bunch of suns that are together being held together by gravity with no planets around them. And if the planets come in and try to hit this gigantic ball of suns, well, what happens is that they either get caught up in there, or they'll come off, but they're not going to come off in a way that's going to be reflective in any way. So we're not going to be able to see this. So if we send, obviously if we're sending waves of G1 particles at a black hole, it's not reflecting off of it the way it normally would. Does it mean it's not reflecting? It could be completely reflecting off of it, or it could be gathering them up. I don't know. My father and I can only solve 77% of the universe that we don't know any explanation for. I'm just kidding, folks. I'm kidding. I'm not giving anybody a prize or prize money to show you that I'm right, that I deserve my father and I. No, but it is interesting, the model. There are several ways. That's why we call it hacking the universe with our model. That's all we do anyways. We're a bunch of hacks. Wait a minute. You don't believe me? Hey. Over here. There you go. Universe hacker. Oh, my hair's all messed up. Doesn't matter. Oh, because your hair's messed up means you don't take care of things, because I'm a big thinker. My brain's bigger than all of you. And because my hair's not messed up, because like the guy in my movie, Einstein Wrong, the kids in my movie came up with, he says, well, the reason Einstein, his hair is like that is because he doesn't care, because he's thinking great thoughts and it doesn't matter to him to look good. It's more important to understand the universe. So if I make my hair like that and crazy, then I'm smarter. David, if I have a model, how would I put it to you? Aaron, David, I seen that the video, but what are they according to you? Okay. David, if I have a model, how would I put it to you? Well, I will tell you honestly, when I look at other people's models, the first kind of thing I do when I look at a model that's not my own is how complete it is. What is it missing? That, for instance, a model, the reason my father and I have a model is because all the models we see missing something. Ether models, which are really great models, miss the idea. They're light-oriented models. That's why they make ether, to describe light. Graviton is only the graviton. Well, our model happens to have both the same particle. That's why we started our model. But when I look at other models, I say, does it have infinity? Or does it have one magical particle? If it does, you have to say, okay, I understand. You believe in magic. That's okay. Well, let me see your model according to your magical particle with its magical attributes. Fine. Look at Jeff Yee's model. The reason I like it is because he's pretty much copying very similar things to mainstream, but he's using a lot less equations. He's using a lot less variables. The guy who won the Nobel Prize and pretended to find that, the one that if you go to David, what's his name? I'll go to the Mach-In just a minute here. The Mach-In. I'm going to go to the YouTube channel, and I will find, there we go. I'm going to find the Mach-In, but he talks to the guy who supposedly solved the problem. I believe that, in fact, that Jeff Yee's model, even though that it doesn't have infinity in it, even though he uses waves, it's a much better model. And the model that, in fact, this guy who won the Nobel Prize, the Mach-In, for, and you can see that, what? Alexander Unsicker, sorry guys, I'm trying to get it to for you. There we go, Unsicker's Real Physics. He's got a pretty cool beginning. He's almost to 1,000. Go! You know, when I started my channel, he only had 370 some. I keep touting him and go, go, go. He's almost up to 1,000. I take full credit for that. No, he has great channel. You should subscribe to it. His videos are there. Where is his video? That's one of the most viewed videos because he interviewed. There it is. David Gross. I should remember that. He's Gross. David Gross. And he is, he's got 5,000 views on that, which is pretty good for his channel. And he interviews Nobel laureate David Gross, who talks about arbitrary numbers on physics and how that he supposedly solved them, and he didn't solve them in any way in reality. So what I would say is, I look at something and I say, okay, yes, Lee does not have infinity. I'm not sure he could open the door for it. He may be able to open the door for it, but he has a much simpler model. I know how the simplification goes, where he has the wave equation to the equals mc squared equation, puts them together, and then he can simplify things. Much better model. So if you are subscribing sort of to the standard model, that's why I think it's a great model. Ether and gravity, he's going to have that problem. Infinite, he's going to have magical particles. Yeah. Does he say why standing waves exist and how come they stay there in standing waves? He doesn't say that. He says that particles are made of standing waves. Okay, so you have to look at the model. So what I would say to you, Aaron, is I said I'd have to look at your model, and if the model has so many buzzwords or words that are not real, like energy and things like that, and you talk a lot about energy, for instance, or you talk about things where when you're describing your model, you say one thing, then later you say something that that it contradicts what you're saying, and that's what happens with a lot of people's models when they're just talking about it and sort of formulating this nebulous model in their head. What they do is they start talking about it and they say, well, I'm thinking about it this way, and I'm pretty sure I think it has something to do with this. And what happens inevitably in that model, you're going to end up contradicting yourself, and that's what's called, one of my favorite word from Glenn Borkert, consumpanability. What is consumpanability? Consumpanable? When it took me 10 years to understand that. It's not that hard. Consumpanable means it's logical against. So if you have all this model, it's got to be consumpanable. What does that mean? You can't have something over here in the model that contradicts something over here. Mainstream is full of that. It's not consumpanable. So that's another thing I do look at, is consumpanability with a model. So that's what I do. So if you have a model, I'm going to take a look at it. You're going to start describing it to me. Am I going to see you start moving around from over here to over here to over here? And do I start hearing contradictions? You'll say something over here that I said, okay, I can see those assumptions that you're making. Now I'm going to make a statement over here. Well, now I think gravity works as, well, wait a minute, you said this over here. So are you saying this or are you saying this? And then you say, no, that's not important, or I haven't figured that out, or no, I didn't say that. And then a person corrects it. Then they end up backtracking the words they say here, and then I have to get my recording out and play it back to them, and then they either get mad at me and say, well, do you want to know about my model or not? And I said, yeah, but if I'm not gonna lie to you. I'm your science therapist. I'm not supposed to lie to you. So I have no problem listening to anybody's model. I always love having models. That is really great. Because I'm talking about consumpanability, don't go away. I'm going to come right back. It's in my other, hold on. You can still hear me. I'm still yelling for me. Be quiet, dog. Universal cycle theory. Hold on. Here we go. The scientific worldview, the 10 things. I'm coming. Yes. I'm getting all these things. Yes, yes, yes. I'm coming. I'm coming. I'm coming. I'm coming. I'm coming. I'm sorry. I'm going to keep these over here from now on. Sorry about that. People are leaving. See, somebody left. Okay, folks. Great book. I have this. I'm not sure they're even for sale anymore. The 10 Assumptions of Science. This is better than Kuhn. Thomas Kuhn. If you've read Thomas Kuhn, read this book. It's going to be on my list because it's just, but in this book, if you don't want to get just this book, you need to get this book, The Scientific Worldview, which says on it, beyond Newton and Einstein, which it certainly is, understanding the universe mechanism of evolution. In here are the 10 assumptions of science. The assumptions, part 2, 25. Don't worry, can't see it. Scientific Worldview. Probably even a better book than the other one, but if you just want to read the assumptions and just what those are, here, consumpanability. I'll even read it in here. Where are you? Irreversibility, complementarian, conservation, inseparability, uncertainty, relativism, interconnection, consumpanable. Well, maybe consumpanable is part of an inseparability, uncertain, complementary, irreversibility. Well, it's part of something else then. I'm lying to you. But consumpanability, let's see if we have it here. Consumpanability. Page 6, 12, 22, 33, 116, 130, 118 to 119. So I'm sorry. They're there, and I actually have a video on this, but it's definitely worth it. Consumpanable is just a term that he's using within all of this. I'm sorry, guys. I read so much And then this is the one that really blew my mind, where you really get an idea of infinity. And believe it or not, this is a conjectured structure bigger than anything we can see now. That we can't see this because we're just teeny part of it in here. And so this is showing the infinity, that you go up and that we're like, you know, our galaxies are particles, and they could be particles. They could be in light particles at a level way, 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 way up there. So, oh, cool. Adam Lohr's got a lattice model. That is so cool. Yeah, I've said that before. Absolutely. In fact, Adam, yeah, send me information. You probably, maybe you have. Email it to david@dissidentscience.com. Yeah, absolutely. I'll take a look at it. We're needing somebody. I need somebody for the Science Woke website. We need lattice people. So, boy, not many comments tonight. Either I'm talking away and people are like sleeping and watching something else, or what time is it? 10:30. Okay, 9 hours. So, alrighty. So those who haven't seen, here we go. I'm going to do it again. Here we go. Turn down your volume. If you're somewhere where you have the volume up so you can hear me, but I've got my good microphone here, so. But we're going to play the stinger one more time before we're going to be going pretty soon here. Here we go. Stinger. I know, it's great. Great. I did none of that myself, except I did do the logo. I do logos and stuff like that. I am an artiste. I've told you that. Those people, oops, I see people are already, that drove people away. It's like, oh, that's the end of it? They left. But I greatly appreciate people coming here. Questions, great. If you do have your own model and you want me to take a look at it, I will happily do that. I'll be very honest with you. I am very encouraging to people, especially if I think it's a good model, like a lattice model. I'd be very happy to talk with you about it. You know, I will tell you what I can. The people I usually communicate with and continue to communicate with are people who are constantly taking observations, not even criticisms, but people are pointing out observations that I think that are important for someone's model, and taking that into consideration and answering those questions or trying to find out what that is or what that isn't. And you know, that's an important thing. So absolutely. I think I've answered most. It's been a quiet time here. So if I go back to the original thesis here, what happens with these people is they're going to constantly tell you, show me you can do the math. You don't understand it. That's the reason you have objections to it. They will never look at the criticisms when that's another thing. People will make sweeping statements as well. Here's one for those who are still around. Here's an exercise I always give people. I haven't given this exercise to people. Go out and find all the proof for special relativity. You're going to find some really squirrely. Do it. I know. I've done it. I have other people do it. And people even during my chat, actually, who were we were talking about special relativity at the time, said, well, here's a page. Go look at it. And if you look at the page and you look at it's a lot of smoke. And there's a lot of evidence against it, like no mass increase. Oh, that's another one. People say, Dave, if you go to my video, which has almost 10,000 views now, which for me is like 1.5 trillion, because maybe someday it'll have a lot. But what they say is, Dave, you don't understand. There's no mass increase. It's inertial mass. And you're going, what does that all mean, Dave? Well, I'm your science therapist. Let me tell you. Inertia is inertial frames. And that means things that are moving have they have special characteristics. I'm in an inertial frame, and that it really means nothing. There are things that move, and so inertia is something like it's moving. So because you have a particle at rest, and now I'm going to accelerate in its inertial frame, that mass is different. So when I measure it, when I'm looking at it, of course, I don't see mass increase. There's an energy increase. It's mass. It's an inertial mass. Even funnier than that is its relative mass is changing, meaning it's only because it's moving relative. No, that's not what it was. That's not the word people are using. But anyways, it's really funny because all they do is they just give it another name. All they're doing is renaming it and say, Dave, oh no, you don't understand. You're giving it the characteristic of mass. We don't mean mass. We mean inertial mass, and that's very different. So it's just the good thing is that when you look for proof, when people say 1,000,000 times it's been looked at, 1,000,000 places it's been shown 1,000,000 times. Neil deGrasse Tyson said that on a very famous video, in my opinion, famous video where he was asked, could Einstein be wrong? And his first answer was, ha ha ha, laughing. And he says, no, it's proven 1,000,000 times a second in particle accelerators to be correct. No, Mr. Neil deGrasse Tyson. What happens is that we use relativistic kinematics. That is, we use relativistic equations that therefore have extra mass. We happen to use neutrino, which people do not study like Karazani to find out that it was invented so that it would take that mass away, when we really measure in Newtonian terms, it all works out without any relativistic equations. We use autodynamic, which are Newtonian equations, and they work out fine. They don't understand. They don't even look at that. And the arguments they make against it are, so those are the kinds of things you see. You have to recognize it. Remember, say, oh, that's silly. You know, we have this explanation. Do you want to debate, or you just want you to show that you can regurgitate, as somebody says, or you can parrot, and then I can parrot that back to it. So if I would go back to this one guy in my comments and would go step by step and draw out and talk about exactly and use the words, even though there are parts of those places in that derivation which I will absolutely disagree with, I would then pass them. And I could go to a university and get all the way through and then ram it down their throat that they're all wrong. That would be interesting. That would be a great documentary. What you do is you get a person, I don't know who you find, but they would basically go and get their doctoral degree in physics and just parrot everything back the way they're supposed to. And then when they get to a place where it's very important, they're just going to slam it and say how this is all wrong. That would be nasty. Well, Steve Beck, I'm working on my particle model still. We've already solved. I'm kidding. Good. Maybe you have a better model than ours. Because that's all that matters. You have a better model or a worse model. That's it. Does your model predict stuff that isn't predictable? Can your model do interesting things with the universe? That's all that matters. You can have a model all day long, but if it cannot predict anything, if no engineer can come along, use your model, and come up with something useful for the world, that means, what good is it? Why do you even have it? Because I have a model that you can never prove, you can never use, and I can never say that anything I'm saying is true. That's why we're trying to come up with a physical model, and my father and I, because we think that we can measure things, and we're already looking at predictions that are there. If the G2 particle goes at c squared, or at least really fast, you think that c squared would be interesting for like communicating long distances in the universe? How long does it take to get to Mars? Anywhere from what, 13 minutes to 22, depending on the distance and how we're doing that communication, whether it's through, or we could use G2 particles, find out how to send those in waves like we do. That's what communication or magnetic waves are. Send those waves, and I've calculated it's about 1/4 of a second to get to Mars at the speed of light squared. Now if your model says that exists, and then you have a model and some technical person tries to figure and can figure out how to actually get in there and use it, then it's a useful model. Wow, people are still joining. Hey, you guys, thanks so much. Any more questions? Because I'm pretty much, it's 10:39, 10:40, 1 hour and 40 minutes. The main goal of this model is to explain magnetism and static electric fields using corpuscle terms. Okay, sounds similar to what we're doing, but it'll probably be different. Make sure you watch the Denis effect, Lionel Denis. Good, Steve. Very interested in knowing about it. We're looking for people for our website who have models. So, if you're willing to put it out there, not be, Steve, come to our conference. Who else has a model? Adam, Lore. Oh no. Iron has a model. Aryan. Steve Beck has a model. Adam Love has a model. Why aren't you coming to our conference? We can talk in person. You can tell me all about your model in person. You can give a paper on it. Very much to think about. And it's June 26th through the 29th at the University of Washington. We even have the room. We know what room it's in. We have the stay there. It's like 45 or 50 bucks a night. It's cheap. No excuses. And if you're working on a model of the universe, that's the place to be. There ain't no other. You can't even go to other ones. For instance, Electric Universe is really great, but if you're not electric, forget it. You're not going to be in there because that's what they do, and they have their absolute right to do that. But ours is the best science organization in the world. Yes, I believe that, and that's because we allow people to present scientific ideas supporting anything that's good. It will also have equations. Equations. Cool. But think about it. Because I'm too busy living the Einstein life. I tell you, folks, you got to come by. You got to get out there. I will tell you, there's one thing that I don't believe, and I have a different belief these days on this, because I think we get to a point where we do have, just like computer programs, we've come to a point in our technology and our knowledge of human knowledge. We have things now that are bigger than one human. Very simple idea for that is Windows, or an Apple computer or Windows computer. There's nobody who understands everything about it. Nobody. There's not a human being on earth, not even Bill Gates himself, not even Wozniak from Apple. Nobody knows it all. We are building systems now that are bigger than ourselves. That's the same thing I think that's going to happen with models of the universe. We are not going to have one person sitting in a corner somewhere who solves it anymore. I think we're past that. We're to the point where we are going to have to, and I'm going to write this down because this is a brilliant idea. I've been thinking about it, but I got to write it down. Well, I'll get myself a piece of paper right over here from the printer and say that we at a point where models will be more cooperative. And that's what our model is, because our model is standing on top of a bunch of other people who didn't cooperate with us, but we certainly listened to them and we incorporated their stuff. But I really think that's what's going to really happen. I am from Michigan. Steve Beck. I'm from born in Michigan. Well, I was born in Ann Arbor, Michigan. Went to not Upper Peninsula. I went there all the time for vacations. And Adam Lore's in Washington. I will try to go. You better go. Adam Lore, this is a command. You will go. And I will tell you, the people I tell to go and they end up going, they come back to me and says that was the best thing I've ever did, because if you are working on your own stuff, here's the reason you need to go to our conference. There's no place on earth where you're going to have more people who are going to understand what you're saying. Because most people don't give a flying whatever about any kind of theory, new theory. Forget it. They don't care. They don't care. Your friends don't care. They sort of, oh, that's nice. Oh, he's doing the theory. He's like a smart guy. Do they care? No. Are they listening? No. Well, our conference, they're going to listen to every word you say. Just like if you want to present on Saturday morning in our Saturday morning conferences, you can do that. But if you go in person, you're going to have an amazing time, because all you're going to do is be able to talk about your stuff with other people who are going to be interested, who are going to give you great feedback, and who you're going to hear talks about things that are going to blow your mind, and they're also going to inspire you for your own model. There's not a person that I've known who's gone to a conference who actually participated in. Some of the people who go actually sort of are very shy. They're sort of more reclusive. They're more antisocial in the sense that they're not a social person. This is not a criticism saying they're bad people. That's the way they are. And they sort of withdraw. They're not interacting. But if you go to the conference and you interact, you go to the talks and listen to the talks, it'll blow your mind. Every time I go to every conference from the CMPS, the MPA before, there were at least 1 or 2 or 3 talks that blew my mind, that I would never trade for anything to be there. So please, I still live in Ann Arbor. Whoa, my dad went there. I'm a Buckeye, and that's why my dad's got a same one. We made hats that are together. See, there we go. Universal hat. Guess what colors those are in? Steve Beck. Yeah, scarlet and gray. My father's is in what? Blue and yellow. Don't say that. Maize and blue. Come on. What are you talking about? Yeah, I'm from your town. I was born there, and I lived all of 2 months there. That's all. I was born on Friday the 13th in Ann Arbor. I'm a Buckeye, and the doctor who delivered me was called, and it's on my birth certificate, Dr. Botch. For those people who are not English native speakers, botch means to screw up. I botched that up, means I screwed it up. So I had Dr. Screw Up deliver me on a Friday the 13th, which in America is really a bad luck. And I was born in Ann Arbor, the enemy territory of my football team, my university. But I love dearly Michigan because we beat you the last 7 years. People are leaving. Okay, guys, I'm going to take off. It's 1:50. Listen, Steve Beck, Adam Lohr, everyone else, one house equation to everything will be able to question our own beliefs. Otherwise, you are stuck. Yep. One house, exactly. Rhino. Thank you, Dave. I'm a newbie to your site, and it has been a first live chat. Love it. Thank you so much. I appreciate it. You do get a lot of different things because I do ramble on, but a lot of times you'll find things, and I will tell you things during the live that I will not tell anywhere else. I'll shadow you. I'll give you like you saw the thing. So I'm going to end it with that, and when I come back, I will sign off here. So I'll end with my stinger here tonight. Thank you so much for everybody for coming by, and I will end it with my new, Ohio State. I went to Ohio State, Bachelor's of Science in Mathematics and Architecture, and my Master's in Linguistics for Computer Science, Artificial Intelligence. That's my area where I made a living. So, all right, folks, here's my stinger once more. Enjoy it, because you're going to see it every time you see one of my videos, at least for a while until I change it, because I'm tired of that spiel. I'm sure you are. But here it is, right before I sign off. Remember, I'm David Hilster. Stay critical, stay thinking. Say that wrong every time. Try it again. Here we go. No, I'm not going to do it again. Anyways, stay critical, stay thinking. I'm David D. Hilster, your science therapist, trying to get you the promised land of, in fact, becoming Science Woke. ScienceWoke.org. Sign up for it, because when we are going live, you will be sent out an email to let you know about it. We're going to have a weekly newsletter on it. Sign up for it. Become Science Woke. Ciao for now.